Hey everyone, so just a really quick follow-up to our Excel exercises from last week, calculating mean, median, standard deviation, quartiles, all that good stuff. And so what I just wanted to provide you guys with was a quick guide to how you can use formulas that are built into Microsoft Excel and actually into both OpenOffice and LibreOffice. So they're slightly different in structure, but in principle the same. I'm going to try and get you guys a guide to the parallel functions for those other pieces of software. But basically, you know, in reality, as I'm sure you guys realize at this point, most of the time you are probably going to use the built-in functions because it's much faster to actually calculate your various your various sort of statistical measures here. But it is really important that that you understand, how to do it by hand, because it will provide you a way to double check the formulas, right? Make sure that nothing got left out, you didn't miss a row, et cetera, et cetera. Provides a really good reality check, because very often when you do this kind of work, you're not going to have somebody who can kind of look over your shoulder and tell you whether you're doing it correctly or not. And so it's good to have multiple ways to validate your results. So that being said, obviously we're going to use it as a check in this case on our sort of hand calculated values. It's really pretty simple. So, you can see in my file here, obviously I have this sort of work column that I did. I have my squares of difference and z-score over here. And so just so you understand how this works, all these are just additional formulas. So again, with Excel, I always indicate the beginning of a formula by typing an equals sign. And then in this case, so when we say average, we mean arithmetic mean. So we would expect this average formula to return the same result as our calculated mean. And all I need to do here is select my data rows. And hopefully I will get the same thing as I did in my own calculation. So that looks good. I have here my mean up here is 98.2. Looks like it matches. Now the next one I can do is I can also do median this way. There is a median function, and I can check that. Right, again, and I don't have to do this selection, so just, to recall that I can actually, when I'm creating these formulas, I could actually copy sort of this part of it, because most of my formulas are going to be in reference to my original data cells. But anyhow, so I have median. Now let's say I wanted to do quartile. So you see quartile here, and it's going to ask me for the array. So again, it's asking me, when it says array, it actually means what are the data values. And then it's asking for the number, there we go, the number of the quartile that I should include. And so I'm going to say 1, and I get 99. Now, again, I could do that reselection. I could just say, hey, it's the same formula, except I'm looking for quartile 3, right? It doesn't really have a function for top and bottom. Oh, actually, look at what happened there. So this is interesting. It's given me an error. So I'm going to check this out. It says formula omits adjacent cells. So what happened there, right? I copied that formula down, but as we know, when I copy a formula down one cell, unless I use that dollar sign, it's going to actually shift the values down. So I need to actually make sure that this is S2 to F76. So one caveat on that, rather than copying the entire formula, I could actually just copy kind of this sort of cell reference part of it, right? And have that on my clipboard for use later. So I've got my mean, median, and quartiles. Top and bottom, I actually don't know that it does. That's not necessarily it does interquartile range. Yeah, it doesn't really do the IQR. The IQR is perhaps a little bit less used, but you get the idea. Obviously, if you have the Q1, Q3, and median as verified by Excel, it's a simple step to do the additional calculations. So now let's take a look at our standard deviation. And this is actually going to highlight something that we kind of glossed over a little bit in our original calculation set. So you see here that I have, so STANDARDIZE, which is actually going to be our z-score, because remember it has a few names. It has z-score, normal score, or so-called standard score. That's why STANDARDIZE is the name of the function. I see something here called STDEV.P and STDEV.S. So as I said, something we kind of glossed over is that there's two different forms of the standard deviation. The calculations are nearly identical with one small exception, which is that when we calculate the standard deviation of a population, aka .p, we add up all the values, we calculate the values and divide them by n, i.e. the number of rows, the number of readings that we have. When we calculate it for a sample, that's the .s version, we divide by n minus 1. Now what this is supposed to do is basically account for the fact that when we use a sample, and we discussed sampling a little bit in week 1, obviously not how to do it specifically, but kind of the principle and what it accomplishes, is that there's more variation. We have less certainty basically when we only have a sample of a population, and so the n-1 kind of broadens sort of broadens the measure, kind of builds in a little bit more margin of error in the breadth that we create. With the population, and to be perfectly honest, we really should have used the sample formula, the standard deviation for a sample, because the number of times that we have access to an entire population, or our data set actually accounts for an entire population, are extremely rare. So for example, if I were doing something, I think we mentioned this example of, if I were doing something about, students in a J school, it's conceivable that I could actually sample my entire population because there's a few hundred students. I have potentially ways to access all of them and also to verify that I've gotten responses from all of them, and then I could use the population calculation. 99% of the time, the S population is actually correct, and so I'll show you how that would change our original work. So STDEV.P again is going to be saying, look at this same set of data, right? So you see that I get a matching value because I did the .P. So in this case, my standard deviation, it would be, rather than divided by 74, it would be divided by 75. Rather than divided by 75, it would be divided by 74. And you can see that shifts my values. So then the question is, and again, you see how it shifts the values, which is one of the boons of keeping my formulas live in Excel. And if I did this correctly, I think, there you go. So you can see how there's a difference. There's a difference there. The standard deviation is a bit broader. It's saying, there's a little bit more uncertainty here. We can't be as precise about the spread. And so actually really most of the time you're going to want to be using that stdev.s, or the equivalent in the sort of manual formula is that rather than dividing by the total number of readings up here, you're going to divide by the total number of readings minus 1. So that's just to flag that. And then to do our normal score, and of course remembering that we only have one unique normal score per unique value in our data set, I'm going to use the standardize function. And when I open up this parentheses, you'll see it actually asks me for 3 things. So it's saying, what's x? In that case is my value, of course. What's the mean? And the mean up here is 98.2. Right, I've got my cell reference in there, and the standard deviation. So I'm going to go ahead and use my new standard deviation. Well, I'll use my old standard deviation so as not to confuse things too far. And it has now gotten sad. There we go. Right, and I can see that yes, this matches. Same thing. I can still do one for my. I can just do one for my 84 value up here. So standardize, and then I'm going to say x of 84, mean, and standard deviation. But you see how these things are all dependent on each other, right? So, oops, I used the wrong one, didn't I? Oh no, interesting. Maybe I did it wrong the first time. So that bears checking. S3, mean, standard deviation. That does not seem to match up. Neither does that one. Interesting. It's off. Oh! Looks like I've got something to check in there. Not quite doing it. The point that I will make, so I will come back to that. Just the point that I want to make too, though, is that in Microsoft Excel, the standardize function requires you to input 3 different values, the x, the mean, and the standard deviation. In reality, in OpenOffice, for example, it just requires you to indicate the data set because actually all of those other things can be derived from the data set. So a little bit of an extra work moment in there for Microsoft Excel. But I will be back in just 1 minute and I will explain to you what happened once I figure it out. Hang on just a sec. And mystery solved, and reason to be aware of whether your formulas are live or not. So what happened here was actually, because all of these formulas are live, we can see that when I changed the way that I was calculating my standard deviation, it actually trickled through to my squares of difference and z-score calculation. So actually, to get my figures to match up now, I need to use my new standard deviation of 3.39. And when I do that, I do indeed get the value that I expect, this 2.357, et cetera, et cetera, et cetera. Again, if I were to return this, right, then I would want to do it by the old standard deviation, right? And then I get the matching again. Anyhow, not to raise too much confusion, but simply to point out that normally when we do standard deviation, we do the standard deviation on the sample, which means dividing, when we get to the sort of second to last step in our manual calculation, dividing by n-1 rather than n. Everything else remains the same, and it just means that when we go to check our values in Excel, we want to make sure that we use that STDEV.S rather than .P formula. So hopefully this will give you guys a chance to sort of go through and just do a quick check on your values. For most of you, this worked out. A few little hiccups here and there. But if there's anything you don't understand, of course, please feel free to reach out via email. I will also have some office hours on Monday afternoon. And I hope you guys are all having a great week. Really looking forward to seeing your pitches tomorrow evening. And yeah, take care and have a great weekend.